Hey Jeff, so great to
Hey.
spend some time with you to talk about Nix. For those of you who don't know Jeff, I got to know Jeff because he was in the past working on, for example, Gitpod, which I use a ton, and he's since kept pushing the boundaries in sort of like cloud environments through working on Coder, etc. And I've realized that Jeff and I share a lot of similar interests in various rabbit hole topics, among them Nix. And since I've done some videos about Nix, particularly on Nix on macOS before, I wanted to take the chance and talk to Geoffrey about some of the topics where he's gone way deeper than I have. So particularly, I was very curious, like, how can you not just there's not just like one operating system, or but there's like a whole plethora, like namely Linux and macOS and Windows. And when you're working on one, then sometimes you also got to test your software on other environments. And so what I was kind of frustrated with in the past is like using sort of like these like Parallels desktop or these sort of things when I'm working on Mac, that I can test things on Windows. And it seems like with Nix, it's pretty easy to get other development environments or testing environments running on a Nix machine. So that's what Jeff figured out, and I want to learn from him. And that's what we're gonna dive into. So Jeff has a nice blog. I'm not sure, maybe my firewall is blocking off the images here, but check out Geoffrey's website. And also for those of you who are new to Nix, I think there are some great resources to get into Nix. We're not going to cover the fundamentals today. There's Nix.dev, which is what I've used back in the days to familiarize myself with Nix. There's now also a new resource, which I really like, Zero to Nix. And so the TLDR on Nix, if you're hearing this the first time, Nix is a bunch of different things. So there's like Nix sort of like as a build system and a package manager. So it would replace your homebrew, but you can also use it as a full-blown build system for your machine, for your project, etc. You write, if you need to express something with Nix, you use the Nix program language. If you want to go all in, you have like you have sort of like more Linuxy machines you deploy your software on. You can use NixOS, which I do if I'm not on macOS. And given that Nix is at a core a build system and package manager, you can then also put those, or like there's a lot of off-the-shelf already packaged things on Nix PKGs, which is a open source GitHub repo. I think one of the biggest GitHub repos actually.
It is.
And so highly recommend just getting started here. But now we're going to dive in a little bit deeper on a particular topic, which is if you have a given NixOS machine, so one of those guys, and you want to run a virtual machine, like starting with a virtual Windows machine, how would you do that? And that's where I would ask to hand over to Geoffrey, and I'll go into the mode of just asking questions, as I don't understand a lot of those things and would like to better understand them. So yeah, thanks for bearing with me. And again, hi, Geoffrey.
Hi, that's a great recap. So that's really important. When someone says Nix, be specific. Like someone has a critique about Nix, they enjoyed something about Nix, or they had a pain point. What do they mean by Nix? Because it's an overloaded term. Like the Zero to Nix has like 4 different particular things, but there's blog posts out there called "Stop Calling Everything Nix." We can put it in the show notes, and there's like 12 different concepts conceptually, and all those concepts combined make Nix. For example, someone might say they're having problems with Nix, but what do they mean? They mean there's a particular package missing from the package manager. But having said that, the Nix packages, that's strange. It's one of the biggest GitHub repos on GitHub of like open source community. It's like #1 community one right now.
Exactly.
And it's, as far as I'm aware, it's the pretty much it's completely under CI/CD, and that's super rare for Linux distros, where you can submit a pull request and you get validation in 5 minutes, something working or not working.
It's
so
super
it works.
responsive.
Nix,
like I used to use a lot of homebrew in the past, and once in a while, like it was whenever new software was released, I was like, one, excited that there's a new version, and second, terrified of like how many weeks I might have to wait to like get on a new, like, this is not to take it out on homebrew. This is just to say like that Nix packages are moving even quicker, and there's typically always someone who's already submitted something. There's like a lot of different versions. There's like alpha versions, and just super nice. Anyway, there's way too much to cover that we could do this justice. But yeah, now there's more and more learning resources, and now we're gonna go deep on a topic. So if this is flies over your head, maybe pause, learn about those things, and come to it later. But I'm very excited to go into a topic that I know nothing about, but I would love to learn more about. So, and Geoffrey has been pushing the limits there for quite a while now.
Sure thing. Yeah. So Arch Linux is typically known as fresh packages. If you think of like Arch Linux, the amount of fresh packages, Nix packages is like that much more on freshness. Like it is, if you want a bleeding edge stable system, because the CI/CD, Nix packages is amazing.
It's not just like Arch Linux is just Arch Linux, but Nix packages is cross-platform. Well, except Windows, to my knowledge. But it has pretty solid coverage for macOS. And just like now that we're also increasingly living in sort of like a cross architecture world, where there's like Intel and ARM, etc., and then there's like Intel and ARM on Mac, Intel and ARM on Linux. Nix packages has this like factored into the foundation, and so if there's a package on Nix packages, then the chances that it's cross-platform is pretty high, and it's being filled in. So anyway, let's dive in.
Let's go.
And I think the best way to start is like I enjoy like getting an intuition for something through a diagram. So looks like Geoffrey has already prepared one. So what are we looking at, and what are we trying to do?
All right, so this is going to be the reference point of today's video. I've been playing around trying to find the peak nirvana for like development tools, build systems, and I've been dog fooding. And what I want to show is what I built, and then show the concepts behind it, and then show how yourself you can cherry pick certain parts of this. This is all source code's available, and you can cherry pick those things, and you'll be able to replicate probably about all the machinery. But I'd like to show some of the things that is possible if you invest in build tooling. Like I think it's really important. Yeah, I think it's really important. So first thing first, I'm going to start here. So I have a bare metal server. It's a Xeon box with many cores and 64 gigs of memory. It's hosted in a data center that's about 23 milliseconds away from me. I'm normally traveling around everywhere, and I've got to a point where my local device doesn't matter. And even if my local device did matter, I get so much more compute in a bare metal machine hosted in a data center. And also not just compute, it's all to do with network latency as well, or bandwidth, right? So I at times I'll be camped somewhere in a forest, and Starlink is great, like solid, highly recommended. But I've got to the point where every time I do a task and activity, I create a brand new developer environment. And that developer environment is for Linux, Mac, and Windows. Right. And I'll show you how that all works.
Most people know how, or like notice conceptually from something like Gitpod or like GitHub code spaces, these sort of things. But this is typically only Linux. And I think that's fine to like develop things, but like sometimes you also got like test things. For example, like if you're building a macOS app, then you also, even if you're not building it yourself, But if you just want to like give it a try, test it out, there's like plenty of things where you sometimes also like when you're working in open source,
all the time.
someone is using Windows, you're working on Mac, and somehow it doesn't work on Windows, and you got to debug that. Should you buy a Windows computer now for like the single thing? Or and I think this is where this can come in super handy.
Yeah. So at the most fundamental basis, I've got a machine, physical hardware racked in a data center, and I use NixOS on that. So NixOS, it can be is the operating system of Nix, which is generated from the package manager. It's the easiest way to look at it. Now, there is reasons why you would use NixOS on a bare metal machine. Is because it's pretty much impossible to brick the machine. Like that's a topic that that is, we could go off into a deep hole. I won't get too much into it, but
yeah, if I have a friend who's getting into like computers and like who wants to learn programming and at some point also wants to understand like how like Linux works, etc., I'm pretty much telling them to learn NixOS from the beginning. This way you don't need to like learn apt-get, blah blah blah, all of that. But just get started. Yeah, search NixOS.org is like the most important site probably, where you find like all the packages.
That is the.
And and you have like even configuration documentation, etc. So it's amazing.
So quickly, because we're referencing this in the configuration. So Nix is both a programming language or a DSL. And it can be used to declaratively define a state of a computer. So instead of having to define the particular config for Nginx, here I can use the DSL and I declaratively define the state. And what happens is the configuration is it updates the grub bootloader. So if you apply a bad configuration, like common mistake is a bare metal machine, right? I update the firewall rule and I lock myself out. Like I just send an IPMI remote reboot command and it'll boot up to my last known good configuration. So it's almost impossible to brick a machine. It is like the most perfect operating system for bare metal hardware.
Yep. It's amazing.
That's the shortest.
Like I'm running it everywhere. I'm running it on my Raspberry Pi, etc. And like, yeah, it's anyway. Let's go into
let's get into it
here. So the goal, and maybe we can start with that right away. Is like what I want is I want to not have to buy a Windows machine that just sits on the shelf for like most of the time. For the little time where I need a Windows machine. Or like the Windows running, I don't even need like a physical machine. I want to be able to like log into Windows, like clickety clack around, like do the thing I want to do, and then get move on with my life. So maybe we can start there right away. Like, so you've managed to get Windows running in a virtual machine running somewhere else. So maybe we can start with a demo. And then can I work up way backwards from like how did we accomplish this with Nix?
Yeah, sure. So the main thing is with Nix is I'm running the operating system, and there's particular configurations you'll need to do, and what we can get it goes into those configuration options. But what's really interesting is just learning the boundaries of Nix and the different technologies. So I'll be showing 3 different technologies here. One is I'll be GHuntleyDev, and it's just a UI. I use Coda to generate this UI. And what it does is just provisions this infrastructure, and we go into the particulars how it does. And then that's the network knowledge there if you need to know libvirt or KVM, for example, or the particulars of KVM with Mac or the particulars of KVM with Windows. And Docker, of course, you'll need to know Docker. So these are these particular technologies in use. So I'll show you GHuntley.dev and we'll go into the Windows side very quickly, okay?
That sounds great.
So this is my developer environment. So when I'm doing my day-to-day these days, whatever I need, if I have a particular task, I can come over here and go, I need a brand new Mac computer.
And here we're not talking like UPS dropping off like a package for you, but it's like a virtual machine somewhere.
Correct, and the particulars on how this particulars works. There's licensing considerations. I use this for personal use, and like the times when I need to work on homebrew and I don't have a Mac on me,
Right.
like, or same with Chocolatey for Windows. So I'm not necessarily saying you use this at your company, etc., because you need Intel hardware, right?
Mm.
So macOS and then runs. So you need Apple hardware, for example.
Yep.
So right here, essentially, Coda is just a UI that's executing a whole bunch of commands, and these are the concepts. So I'll walk through the particular configs.
Got it.
But this is my developer environment. So anytime I need a new task, I want to do something, like I want to grab a new Ubuntu machine.
So you've configured it in such a way that you basically have like a very powerful machine somewhere, but you could also deploy this on AWS or whatever. And then on this machine, it would boot up a VM with like
Correct.
that's provisioned the way how you want. And then you can SSH or VNC into it, etc.
Yeah, because like, here we go. Here's PowerShell.
Okay, wow. So this is like now, so we're still seeing this like
I'm in a Windows,
I'm
in a Windows virtual machine.
Well, let's work our way through like the UI here. So first of all, we're here on macOS and Chrome, and then so in Chrome we're now like on this URL, but we could probably also get there otherwise. And now we're like on your remote machine, which runs in like some data center, and your labs stay cool because like your physical machine in front of you doesn't need to do the virtualization. And now we're like kind of the Windows equivalent. Maybe this is SSH, maybe just something else, but now we're like in a Windows shell. And that is like the latency is probably depending on how far that machine is away from you, but should be pretty good, right?
It's great, like 23 milliseconds. It's great.
All right.
So Coda is just a tool that creates infrastructure, and we'll get into the particular primitives. Don't get hung up about particular Coda. If you need a way,
we wouldn't need it, but that makes
build,
it now like really easy. And if you want to do this a lot, then that's probably the way to go. How you can like automate that for yourself. Okay.
And this is a way that I get ephemeral environments. So I can create. I've created one now just here for Windows just before. And likewise, I can go over to say macOS.
Kind of like terminal. Gitpod, just a little bit more like even higher level where I could do even a little things a bit more flexibly.
A higher level, I can do GPUs, I can create anything, like literally anything. It's just whatever I need to do. So now I'm in a Mac machine.
Okay, so this is now like a Mac VM running on your like virtualized on your beefy NixOS machine somewhere. And so now like we've seen two terminals. Truth be told, I don't enjoy Windows terminals as much. And on Mac, I would probably also rather like want to see a visual representation. So can we somehow like get a UI remote access thing for both the macOS and Windows here?
Yeah, sure we can. So of course, I can launch Visual Studio Desktop and connect into it with a remote SSH.
Okay. I
can forward commands, etc., as you need be. Nothing too particular. So let's go into what is going on here. Okay, with Windows. We'll start with Windows. It's probably the best place to start.
Mm-hmm.
So the Windows knowledge is what one needs to know is libvirt.
All right.
Libvirt is nothing particular about NixOS, but there are NixOS configuration options to allow you to do Windows 11.
Can you like libvirt for those of us, me included, who've like hearing this maybe the first time? Is there like an equivalent of libvirt that people might have already heard, like VMware Fusion or something like that, or is it rather that things like if you try to run a VM before on macOS, for example, is this all like using libvirt under the hood, and most people just don't know about it? Is this like a fairly new technology, old technology? This seems fairly integral to this entire endeavor.
It completely is. So libvirt is, I don't know, maybe 18 years old now.
Okay.
Like it's old technology. The way to look at it is it's the Linux open source hypervisor that can run multiple CPU architectures. It normally uses QEMU. It can do everything from like mainframes to like Amigas. And in this case, a Mac or a Windows is just Intel, or you could switch in ARM with the right configuration.
Got it.
But it's a Linux technology created by Red Hat, if I remember correctly. And we'll start with the most basic thing. So if you're going to be creating a Windows VM with libvirt, you need the drivers, because when you create the virtual machine, or what you have to do is create an initial image, right?
Okay.
In this case, every time I go across over here and I create a brand new Windows machine, what it's actually doing, and I'm going to head across. I'm going to head across here. And this is VS Code into one of my environments, just remote SSH, just to make it, as we go through the different layers of interaction, this is nothing special. This is just source code.
And just to understand the like layers here, are you SSH directly into your NixOS machine, or are you SSH
Correct.
into a, like, let's say another Linux machine, or running in this VM?
Well, right now, this session right here is my NixOS machine.
Okay, where the other things live in. Okay, so kind of like that directly the host.
Proof is in the pudding. I'm just going to rebuild and redeploy NixOS live. Like, that's how confident I am that it's going to work.
You're kind of like pulling the rug underneath yourself, but trusting that while you're up in the air, the new rug is going to be there.
Correct.
Okay.
All right, so that's built. Your other question is, of course, when I'm using Coda to create all these machines, it's just an orchestrator. I can come over here and like mash this, and this will create a VS Code. This will create a VS Code remote SSH into the machine.
And this was Ubuntu, if I read that correctly.
This is Ubuntu. Yeah.
And so this is now like running through on that NixOS remote machine. It's through libvirt running a Ubuntu thing, which now also provisions all the stuff that you need. Now you've SSH'd into it with VS Code.
Correct.
Very
so
nice.
Here, I specifically, what I'm using, the technology I'm using for Ubuntu, for things that are containers, you just use Docker. So Coda, when I'm creating this machine, what it's doing is just creating a Docker and running a Docker image.
Okay.
And I can come across here and do Docker PS.
Got it. What if you do Docker PS in that provision machine?
Well, that's the interesting thing, because Docker and Docker and sockets, right? So there's a couple of things here. What I do is I can go over here, settings, and I can expose the socket. Of course, the security implications of exposing the socket.
From here, within that new machine, I could somehow fiddle with stuff from the host machine, which would be kind of like breaking the isolation.
I'm breaking isolation here, but I can hop in this particular, because there's times when I need to access the Docker socket, but I don't have it enabled by default, and you shouldn't for security, but there's edge cases when you need it.
Could I still have Docker, isolated Docker within that thing?
Of course. So here we go. So I'm in the Docker container now, running Docker PS. I've mounted the Docker socket into that Docker container, which means I now have access. So there's things like Docker and Docker. There's rootless. It's a huge chasm.
Like a separate rabbit hole. We don't need to go into it now, but I was
we
just
don't
curious.
need to get into it.
Okay.
All right. So Windows. we went off the track, and let's talk about Windows. So first off, the first thing you want to do to get NixOS and Windows working well.
Could we, sorry to interrupt, before we dive into it, like how it works, could we do like a super quick demo of like how it visually can interact with a Windows machine?
Okay, sure. So this front end, when I've created these machines, it's executing essentially commands to create a copy, a template, and input some create a new XML. And that template is a virtual hard drive. It's a file. It's the contents of the file system, or the Windows file system. And
those get pretty
access
big,
or see,
I think.
yeah. So there's a couple of different things. So one of the key primitives for accessing KVM is Virt Manager. The Virt Manager is available as a homebrew tab on Mac, but it's also, of course, on Linux. And you can do X11 forwarding, or you install the port. On Windows, I don't think it's the solution is that clear. So we are now connected to libvirt, or the KVM daemon, the QEMU daemon. And what we're seeing here is the result every time I create a new machine or a new ephemeral machine for a task. Here's the Schickling one that I created.
Okay.
And this is just like if someone was using, if they're used to using like VMware or OpenBox, for example.
All right. So this is where we can actually see that remote machine.
Correct. And there's different ways.
How responsive is this machine here?
Well, put it this way. It's got lots of capacity, and it's when you're in a bind and you need access to a Windows machine, and I don't have a Windows machine near me, I can hop on this on an iPad, for example.
Got it. But like if you're, for example, on that Windows machine, you were to go to YouTube and play a video, like how, in terms of like FPS, etc., like would this be workable, or is this more of like a slideshow in terms of like?
It's more of a slideshow. Or YouTube or video is more of a slideshow, but there are hundreds of thousands of software developers who do software development under Citrix and remote desktop every day, and they have no choice. Their local laptop is completely locked down, and they jump 2 or 3 levels of RDP in to get to the right machine to do their software development. There are hundreds of thousands of people who do this as your day-to-day work. It is workable, passable, as long as you keep your latency down.
Got it. So could you do something like visual that would just show like a bit of like the latency in that visual part?
Yeah, sure. So here, this is not going to be so great because it's a virtual representation of the console. I'm using Spice Server for this. Spice is another technology, and that actually works quite well, to be honest.
Can we make this bigger?
Yeah, we can.
Okay. And so if you were now just to go open Chrome inside here, like browse a bit, I just want to get a feeling a bit for like the...
Yeah. So the experience of accessing the console directly is not great.
Got it. Okay.
But the way I normally work with that, and I'm doing this live, so I don't know if this is going to work, but I use the Chrome remote desktop. So I use the Chrome remote desktop. I install the agent on the particular machine. When I provision that machine, I then hook it up and it turns up in here, and that's how I access my Windows machine.
That's almost like a team viewer kind of thing, but built into Chrome.
Exactly.
Okay.
Exactly. And from there, the performance is mint. It's just the same as RDP. And of course, I can...
so you would use that instead of the Virt Manager thing?
Yeah, the Virt Manager, you'd only go to troubleshoot. You only really go into Virt Manager to really troubleshoot. You don't use it for day-to-day.
Got it. Okay.
So let's go through the particulars that one needs to know for Windows. So if you're creating a brand new virtual machine for Windows on KVM, you need to configure it in a particular way. The first thing you really want to do is you want to pass through the CPU config if you've got a bare metal machine, you want to pass the CPU configuration through. You don't want to do virtual emulation. You just want to map the same CPU architecture, same motherboard through the virtualization.
Okay.
That's important to do. The next thing is when you're creating your disks, you have to specify, like, is it an IDE hard drive, is it a SCSI hard drive, or what type of hard drive it is. Here we're using a particular type of disk bus called VirtIO. VirtIO is like almost direct pass through. It doesn't try to emulate IDE or SCSI. It's the highest performance. But Windows doesn't have the drivers.
Okay.
So you have to create the machine, allocate the disk drive, and then when you've allocated the disk drive, you specify that it's a VirtIO, and Windows is going to start the install when you boot off the CD, and it's not going to show.
Got it. And you do that as you create sort of like the initial boot machine for Windows. This QCOW2?
Yeah, so I'll get into the particulars of it. QCOW is the image format for the hard drive. And what you need is the driver. So when you're doing the install, it's going to show no hard drive. You press F2. What you want to do is mount this ISO into the CD-ROM drive. This is how I pass in ephemeral information for agent data, etc. Every time I create a new machine, I regenerate this. This is how I pass my tokens and automate the provisioning of Windows. A little bit more advanced. We won't have too much time to get into that. The main thing is also here, VirtIO. So if you're doing Windows, you must install the drivers. You press F2, you get your hard drive up and running. So you can install Windows. When it's booted, you want to run the installer.
Okay.
There's an actual installer, and that will install chipset. It will allow things for memory ballooning and compression.
There seems to be a bit of a chicken egg problem. Like how in which mode do I install that? Like, can I boot the machine without the drivers, then do it? Or like, how would I do that? Or is this like more part of like a build step somehow?
This is more build step of like Windows knowledge. Essentially, you boot off the ISO, press F2, read from that ISO of the driver. That will allow it to load the driver for the VirtIO disk platform. Okay. Then you can install. And when it reboots, you'll have a normal Windows GUI, and then you just run a standard Windows installer for the drivers that installs the networking and all the rest.
Got it. Okay, that sounds a bit involved. So maybe I'll find a way how I can get my hands on like a pre-existing QCOW image that I didn't need to do that.
Yeah. So let's go. You mentioned QCOW. Let's get into it. So I'll go into my definition.
But this repo is this like I think your main repo, which is open source. So I think for people who are curious, can probably see this later.
Yeah, I run everything on a mono repo. There's particular reasons for that. Using Nix, I define all of my dependencies, and it builds all my software, and it caches really well. That's a short answer. So what you're seeing here is standard Terraform. Coda is Terraform, but I don't want you to focus on Coda or the Terraform here. Essentially, what happens is when I create a brand new virtual machine in Coda, it's passing in a source file. And I've got a whole bunch of images here. I've got the original ISO for the drivers, and I've got the ISO for Windows.
Okay.
Now, what's happened is I've created my initial configuration, like I've installed Windows, I've configured it in a particular way, and then I turn off the machine. And then I copy that machine as a template, and this is now my ephemeral template. So every time I create that machine.
You've done that through that Virt Manager thing through the UI?
Correct.
Okay.
And it's just a file, and I use ZFS, so all this is deduplified. It's got dedupe, and it compresses very well. So it doesn't matter how many things are Windows. Like if this is like 27 gig, it's only stored 27 gig once.
That's probably
so
another session we should do. Like I'm not using ZFS. What is it called?
ZFS file system.
Yes, ZFS. I'm not using that, and probably should. We should get into that another time.
Another time. So what we're doing here, when I go File New to create myself an ephemeral Windows, what I'm doing, I'm passing in a file, and this file is this one here that I've created, and I've just copied it on the file system. I've shut down the machine, the virtual machine, I've copied it on the file system, and this is now a golden image. And I'm passing that in. And from there, there's some very particulars that you need to do for Nix.
Quick question for this golden image. Is there like anything, have you already personalized this to yourself somehow, that you said like your user, your password, kind of like that?
Yeah, so I've done a whole bunch of personalizations, like Chocolatey is installed. I've done the latest Windows updates. So I'll start the machine every.
Got it. But you've basically done that visually, like by clicking around, and then at some point you say, now it's good. You turn off the machine, and then you take the QCOW images as it sits there with its bytes, and now this is like your new starting point.
I literally. Exactly that.
Okay, cool.
Like, done.
Nice. All right.
And that's how I create a blessed image.
Okay. Yeah, that helps me form the mental model. So basically the booting, driver stuff, etc. That's like fairly analogous to how you would need to do it. Like if you have a physical machine in front of you, you need to boot, like press the key, etc. And like those fiddly bits, except that once you're done that, and once you're finally at a state where it all works, now you have like a big bytey file, which you can now save and always come back to it.
Yep.
Okay, that makes sense.
And that's how I do my ephemeral. I'm always restoring from a snapshot, or
Got it.
And I update the snapshot for security updates from time to time and whatever. But the point being is I can deploy 100 Windows machines on a disk space basis, and it's only ever going to use like 1.2% disk space.
Yeah, that's amazing. That because of the ZFS.
Yeah. The DG, not 1.2, but anyway, it's late. This is the next thing you need to know about Windows and Nix and KVM. Windows it uses UEFI. Windows 11 uses UEFI, and by default, the UEFI packages are not installed on NixOS.
Okay.
And this is what we're seeing here is the definition of the virtual machine. So one, we're copying the QCOW into a new machine, in this case, Schickling, right? And then I'm creating
what does into a new machine here mean? Like that's coder specific, or in another in a like more bare bones setup would be literally just copying like your template file?
You could do this all by hand. I just use Coda to automate this stuff. Okay. It's best not to even think about Coda, except for it's just UI that runs through these concepts.
Got it. Okay.
So literally I'm copying an ISO file. We have to specify in Nix the UEFI and the MV RAM. So let's get into that.
So right now this was still Terraform, and now we're gonna look into the Nix part.
Yeah. So let's look at Nix really quickly. The main thing that you need.
And this is your host machine, right? This is your Nix host machine, which this is the stuff that you've like configured on your host machine that you can like build, you later want to do two things. One, run those virtual machines there, but second, also like prepare them as we've seen right now.
So this is my host bare metal machine, the NixOS instance, and this is me configuring NixOS with the options you can find on search.nixos.org.
Yep.
And most importantly of all is line 14 here, line 13, line 14, and down to 17. You want to particularly have them, otherwise you won't get the firmware, and then you won't be able to. So even if you do libvirt enable, and you have a Windows ISO, you won't be able to install it unless you specify the MV RAM, and you need these on Nix to provide this
secret spell that connects to the Terraform thing we've seen before.
But it's not Nix knowledge. This is knowledge that you could Google for, like Red Hat. How do I get MV RAM for Windows?
Put into this is how you do it in Nix schema,
Correct.
basically. Schema, not a schema. A quick question, just because I've seen this technology in a few other places. If you could briefly go back to your to VS Code.
Yep.
This QEMU, can you put that, can you briefly say what that is and how it relates to libvirt?
Yeah, sure. QEMU is actually the back end of libvirt. My understanding is libvirt is a bunch of infrastructure patterns, and QEMU is the actual emulator, the actual hypervisor, and the idea is it's pluggable.
Okay, so this is where you've mentioned this is like fairly old, and then there might be like newer implementations that come along, and that they're like probably a poor analogy.
Yeah,
but now
everyone's
like
just using QEMU.
Yeah,
everyone just uses QEMU.
Got it. Okay.
It's really one of the only things, but the idea is it was extension framework. I understand.
Okay.
It's like I learned this stuff like 16 years ago. Some of it's a little bit hazy, so please go check.
Right. Yeah, I'm very new to like everything virtualization. I'm like glad that I got along so far with not knowing all of those details, but now I'm also just a bit curious.
Cool. So what I want to show is if I head over here, got a bunch of XML here.
Okay.
This is the other half, the cookie, that how libvirt works. Libvirt is configured by XML.
Okay.
And there are ways that I have to find a pattern that really works for me, but there are ways of defining virtual machines declaratively in NixOS, and some people have done Windows, but I wanted to have ephemeral, like a task-based and just disposable machines. So that's why I used Coda as a UI. But if we look here on line 9.
So in this file you pulled out of the libvirt manager UI.
Correct.
And how did it end up here in the first place?
When you create a machine, and that's essentially what Terraform does, it creates a machine or a definition. It's essentially a DSL that's created in the XML.
Got it. And it put that on your local Mac machine, or where did it put that file?
So I'm connected via SSH into my machine, bare metal machine. And so this is being proxied and relayed. This is the configuration on the machine.
Virtual machine manager thing is actually the libvirt manager. That is actually you're SSHing into your NixOS machine. And
Correct.
This is how it picked up on the NixOS machine where all of like the libvirt stuff is running. Now it makes sense. I think it.
Yeah. So there's things like
when you opened it that it was asking for like your SSH fingerprint. Now it makes sense.
So there's a command line called vir sh, and it's similar. If you go to the primitive of Docker, right, and it allows you to connect to domains or virtual machines, and you can import XML, you can export XML. This is the low-level primitive of you're either going to be using a graphical tool like this.
Yeah,
this is majority where you are, or you're going to be in the weeds using vir sh.
Got it. Okay. Yeah.
So here, I could actually give you this config, XML config, and this would give you a Windows machine.
Assuming the reference files would also be there.
Correct. You'll need to install Windows. But
this
is the correct configuration with for example, Windows needs TPM to be enabled. It needs the UEFI. It needs certain particular things. You could literally just take this XML, and this is what we got on line 9. Like here, we're referencing the location on line 14.
Got it. So this is basically Nix, where through Nix, you now tell, like, once you rebuild the Nix machine, it now says, aha, like it seems like there's new libvirt stuff needed. So it pulls these down probably from Nix packages, puts them into a certain location. Then your Terraform can point to those things, generate you this XML thing. Now libvirt, so like, aha, new XML thing, start. And that's basically how those pieces are connected.
It's really, it's not simple, but that's what it is.
Okay, okay.
I've got a DSL here that essentially ends up as XML.
Right.
I specify in the particular packages which are installed on there. And this is just a way that I could generate. There are Nix expressions that generate this XML. It's just not the path I went, because I wanted a self-service portal with a level of dynamicism. So that's the main thing for Windows. You
jumped through a lot of hoops to get this to run.
Yeah, but there's a lot of conceptual here. We're talking about bare metal hardware. We're talking a automated provisioner, and then to even know those things, you then need to have knowledge about Windows, like how do you sysprep a machine. By the way, when you first install Windows 11, you will notice you can't install if you don't have a network adapter. But you don't have a network adapter because you don't have the the virt.io driver installed yet. So there's a separate side quest where you hit a particular special combination and you can bypass that screen, and that's like a OEM install.
Which again, I don't need if there's like some off-the-shelf QCal image, then someone else has ideally already done that. Yeah. Okay.
But yeah, it's there's rabbit holes of knowledge here of not just Nix, but Windows knowledge. Okay. So that's the run through for Windows. Pulling all those pieces together, the end result is I've got a portal that allows me to create a Windows machine per task, and I can turn it on, turn it off.
That makes perfect sense now. And just to apply my new gained understanding, if we actually like here you have the Chrome tab, like the Chrome remote desktop thing. So maybe in the future, you might actually say in your QCal like base image, you might have already, the next version, you might already include Chrome remote desktop into that base image, which now could make it even more plug and play once you provision a new machine.
Yeah, so here I've used Coda to delete the Schickling Windows virtual machine, and you see it's flowed through down to KVM.
Got it. So which again, like this thing here is like actually your SSH, this is SSH into your remote Nix machine, which then live updates to, okay, cool. Yeah, I mean, so many interactions.
We're out of the rabbit hole.
It makes perfectly sense now.
Yeah, so virt.sh, show, what is it? What is the command? Whatever, command doesn't matter, but the idea is the primitives is there. We go to images, and yeah, it's been deleted from the file system as well.
Got it. Okay, very cool. And so you mentioned Windows was the trickier part.
It's the trickiest. It is the trickiest part. The OS X is simple.
Okay. Do you think like how much time would we need for OS X?
Oh, like 30 seconds.
Okay.
So there is a pretty cool hacker by the name of Sickcodes.
Sounds pretty sick.
Yeah, he's kind of famous for hacking the John Deere tractor and turning running Doom on a John Deere tractor.
Wow.
That person. He has a particular project.
Oh, love it.
And literally it is packaged up as a Docker container. You do need to pass through the KVM device.
Got it. Okay.
This is designed to be run on Linux. And because remember the bare metal machine is running Linux, we do have access to libvirt and the KVM device. So we bind mount that into the Docker container. And by literally running that command, you will get a virtual machine, a Hackintosh virtual machine.
Oh, Mac. Wow. Yeah, that's good.
It's really
like
simple.
A physical Hackintosh back in the days, which was like a lot of pain with like all sorts of drivers and so on. But this seems like nicely boxed up.
Correct. So if I have a look at my templates here, and this is a template for Coda.
Okay, now it makes sense. Now you can basically just, instead of like all of like the libvirt's crazy stuff, you can now just point it to the Docker image, and it's so much cleaner.
Correct. So here on line 49, I'm just telling the Docker daemon to pull this image, and that's the same image from GitHub. on the line that's highlighted is the KVM. So here I am bind mounting the KVM into the Docker container.
Right. Yeah. This
And
is
the end
basically
result
just the
is
Terraform syntax for that
correct.
Docker command we've seen before.
Yeah.
A brief question. So does this still like use so for like the I'm actually not sure whether it's just for the UI, but like if we were to run this, how can we visually now get into the machine? And is this still using libvirt?
Yeah, sure. So with Mac, I just use Apple Remote Desktop again. Sorry, Chrome Remote Desktop, as the same way on Windows, and likewise for Mac, you can use the Apple Remote Desktop or TeamViewer. There's so many different ways. It's literally a virtual machine that can run anything.
Got it. Would it also now, like if you provision it, would it now also show up in like your Virt Manager UI?
This one in particular, I don't believe so. I haven't gone into SIC codes and his particular implementation.
Okay.
But from here, if I need a Mac machine, I can just go ABC for the task. And what this is doing is it's essentially applying the Terraform configuration. And the Terraform configuration says, define me a new Docker container. It's going to be named to a particular thing. It's going to be like ABC. So I can head over here and go like Docker PS, and we should have a GHuntley ABC Docker container. So this is now pulling the image, and I have KVM bind mounted into it. And if we're lucky,
yeah, how can we connect to it now? I presume by SSH, but probably also visually somehow.
Yeah, once normally SSH is the main way you do it.
Okay.
But you just any one of your TeamViewer or Remote Desktop or Apple Remote Desktop, it's all there.
Yeah.
So right now,
like, shouldn't I be able to from a Mac to a Mac be able to use like the remote screen share thing?
You can. So one of the cool things when you start getting to this level, where you're building ephemeral environments like this self-service portal, is these all have like a reusable tail scale key, and then from there,
amazing. Okay,
like, it's
yeah,
all
tail scale is like another
it's the key. So cool. So this is actually kind of like cool thing under the hood here. So this is provisioning. No, it's started.
Okay.
Done. I've got a machine I've just created, and this is the magic. Some of the magic parts of Coda. Coda is also not just provisioner, but it provides a lot of primitives, like provides the networking between things automatically. It's one of the reasons I use this. So I can literally over here just go terminal, and I've got an Xterm
awesome
on that machine, or I can. Let's configure my SSH. Done. And this is just this is all just Chrome in the end. But yeah, this will allow me to SSH. I'm now SSH'd into that virtual machine, which is a Docker image, And Coda is just providing utilities for SSHing or establishing network or personalization scripts.
Could we do the virtual part also as well with like the screen share, the macOS native screen share?
Yeah, so I don't think it actually shows up here. It needs the KVM device, but I understand why. I haven't really paid too much attention. Like Hackintosh stuff is fragile, so I'm really happy someone is.
I mean, like the actual like built-in macOS screen share. So if you like do command space and write screen share.
Yes, but that would take us onto a big rabbit hole. Not on this particular machine. Not on this particular machine.
Like on the like your physical machine in front of you, or like the virtualized thing?
Not on this physical machine that I'm presenting from. I don't have it set up right.
Okay, like my understanding
is in the interest of time, I would go into a big rabbit hole. But the idea here is SSH onto a machine. I can run any command, and then I can configure P lists for remote desktop and the users and from there I could do Apple Remote Desktop into it, but I haven't actually gone down to that path yet, and this particular laptop doesn't have Tailscale installed right now.
Got it. So basically the SSH coder ABC main does this like or if we can look into the SSH setup that it has done there.
Yeah, sure.
Since like usually the
and this is where we get in the boundary of Coda. This is one of the things Coda does. It provides primitives. Essentially, it's a pretty good portal for self-hosted provisioning developer environments. So what it's literally doing here is when I SSH into a particular machine, it's running a proxy command, and the proxy command initializes Coda. We're into Coda specifics here, but it allows not just creating a virtual machine, but establishing networking. It actually uses Tailscale internally between the machine and
but like not
else.
sort of like in a opaque way, where since I've like been able to use the macOS screen share thing using the Tailscale like hosts thing. So this is why I was just curious, like whether it would just work.
Yeah. So this has been trivia. So when I create a brand new machine, this isn't trivia of a Coda internal. So I used to work there. What happens is I'm creating a brand new machine here. In this case, a libvirt container, or it could be a Docker, or it could be a Mac, it could be whatever. And once that's created, what happens is that machine then heads to /bin and it downloads an agent.
Got it. Okay.
And that agent has a token, and that token then associates itself. So this is why on Windows, if I head over here to the Windows configuration,
you've done this token shenanigan.
What I've got is essentially I generate a ISO, and I attach this ISO into the machine. Every time I create a new machine, I turn it off, turn it on, turn it off. And this is the token that it needs. So this is the startup script. The startup script is literally curl to bash this.
Got it.
It's a token to associate itself. And once that is done, from there, I can have startup scripts like changing what the username password is, or enabling RDP, or etc. And this is also what the proxy command is doing in the SSH config to tie that up in a neat bow. Because once that machine is running the agent and it's associated, it establishes a WireGuard, automatic WireGuard, completely transparent between my GHuntleyDev and all the machines I create.
Super cool.
And then I can run, and it's literally ripped the Tailscale internals that are open source, and it's great. And then you can run Tailscale on top of your own tailnet, but this is an underlying thing. And so that means when I create a new machine, I don't need to worry about networking or any of that hot trash. It's literally just click a button and it works.
A lot through Tailscale, etc. So on that macOS machine, there like you currently have no way to like VNC or like somehow visually display that running machine.
Not a Mac currently, no.
Okay. Yeah, maybe that's something for the next time. But I'll certainly give the SigCodes DockerOS thing a try, since I assume if I figure out like the networking part, then I should be able to like screen share in, I suppose.
Correct. It's just the same as a local laptop. It's in a data center and it's a Hackintosh.
That is super cool. We've touched on so many different pieces here. I'm very curious, like for like maybe a future chat to like go into other parts of your setup that you've explored here, like ZFS. But I think we've also, before we started the recording, we talked a bit about like secret management on with Nix, etc. So there's like loads of topics that I would love to get in a bit more, but for now I have like a bit of homework to do, where I want to like see whether I can replicate some of the things that you showed me. Maybe I'll also give like Coder a try. So loads of inspiration here. So yeah, thanks so much for showing me all of this.
No problem. Well, next time we catch up, secret management is a really important thing. It's so easy to cut yourself. This is a legitimate problem with Nix. If someone's watching this and you want a problem to fix, we need some sort of linter in the Nix ecosystem that ensures secrets are not read into the store.
Right.
And it's more of an advanced topic, but the idea is you don't want to store the secrets in your build artifact.
Right.
And there are particular techniques to ensure you don't do that. And we would need some sort of linter in the ecosystem, and that would make sure the newbies don't make mistakes, don't have InfoSec issues. But right now, this secret management is more of an advanced practitioner topic. And day to day, like I use Nix here, and we can go into it in more details, but you can just Google it. But like literally, I just have my secrets stored on my file system. And I can open them up here, and they're all encrypted. And they're all encrypted with SSH keys. And here you define which hosts or usernames and the SSH keys, or the host key. And the idea would be if you join a project that's using Nix, you'd be essentially copy and pasting your way to freedom here. It's like secret management, like logging, is an infrastructure concern. When someone puts in the right pattern, it becomes very easy.
Right. Yeah. I'm very, very interested in going a bit deeper into that. I've like used or tried out, I think it's called NixOS, or like NixOS. And so I'm like still trying things out there. So I'd love to do this another time and go like deep on that, figure out like the best practices. I think it's going to be very useful for folks. But yeah, I would suggest we wrap it here. It's like way past lunchtime for me, so I'm like getting a bit hangry. I think it's getting pretty late for you as well. So I would suggest we wrap it here, but I'm very much looking forward to doing another session like that, learning a lot, and hopefully this is useful for some others as well. So Geoffrey, thanks so much for taking the time.
No problem. Yeah, I just want to encourage people to really invest in their tools, the build tooling, and like remote developer environments or cloud developer environments, whatever. It's gone between mainframe and thin client backwards and forwards so many times. But the point being is I could create you an account here, and you could use any of my templates, and you can start working on any of my projects, Mac, Linux, or Windows immediately, on any device anywhere. And I think that is really cool. And this is not any unique property of code or any such thing. This is about investing in patterns and techniques. And I think every company should be thinking along these lines of building some sort of self-service portal that allows people to do work from anywhere on any device, and no intellectual property is on the local computer. And it's just, if you're a company, if you're a company, you could, and Hackintosh isn't suitable for you, it's quite literally a couple of lines of code, and you just, you get yourself an Orca cloud with Mac and Cloud. I think it's Mac and Cloud. Mac Stadium. GitHub Actions is powered by Mac Stadium, like clusters from Mac Stadium. So you just go to Mac Stadium, I want an Orca cluster, and they'll give you a way to provision legitimate OS X on legitimate OS X hardware. And then not an issue.
Yeah, I think loads of developers and companies would really benefit from like investing a bit more into sharpening their tools. It's going to make it more fun to work on things, and like make kind of like following the mantra of like make the right thing easy. And I think this is like a very powerful tool at our disposal here. So yeah, very curious to also like dive into this myself more. But yeah, Geoffrey, thanks so much for your time and sharing your knowledge and wisdom here. Very much appreciated, and looking forward to the next time.